Okay, now that we have learned some of the basic differentiation rules, I have a few examples that will show up on your homework, so I want to go through them. First of all, we want to take the derivative of a function that is a quotient, and we don't have a quotient rule. Now I know that if you want derivative of a function that's added or subtracted, you can just take the derivative of each piece. So you can do the derivative of the f piece and the derivative of the g piece, and then add the two answers together, and you can get the derivative of the whole function. And that works with subtracting too. However, that does not work with quotients or products or functions like this, where it's a composite function where there's one function inside of another larger function. So we have to rewrite these because we don't have a quotient rule yet. We will eventually, but it's a little more complicated. So if it's easy to rewrite it, just rewrite it. So break up this so that it's not a quotient anymore. Break it up. Each piece gets the denominator. This is different than a multiplication problem, so with additions and subtraction, each piece gets the denominator. And we'll rewrite it one more time. X cubed over x squared is just 4x. And then the x squareds cancel here. And here we still don't have a quotient rule, so what did we do when we wanted the derivative of something over x squared? We brought the x squared up to the top and made it x to the negative 2. Now we're ready to take the derivative. So the derivative of that, the derivative of 4x is 4 times the derivative of x, which is just 1. The derivative of every constant is 0. And then for this we want to multiply 8 times, multiply that negative 2 out in front of there, and then subtract 1 from the exponent. So negative 2 minus 1 is going to be negative 3. So simplifying this, we've got 4 and then plus 16 x to the negative 3. So we could rewrite that as 4 plus 16 over x to the 3. Or in your book, they may get a common denominator, so they might multiply this by x cubed over x cubed, and then you would have 4x cubed plus 16 all over x cubed. So you could leave your answer like this, that's fine with me, but if it's a multiple choice test or the answers in the back are simplified like this and you want to compare, make sure you know how to get from here to here. Now this function is a composite function. Again, we don't have a rule for a composite function, so you can't just take the derivative of the inside and square the answer. You have to rewrite it. So let's multiply it out. FOIL x squared plus 2x plus 1. And then we can take the derivative. Even after we learn our composite rule, if it's a small power like this, it's going to be way easier to just multiply it out and then take the derivative. So the derivative of x squared is 2x. The derivative of 2x is 2 times the derivative of x, which is just 1, and then the derivative of 1 is 0. So that simplifies to 2x plus 2, and that's your final answer. So please remember, we don't have a quotient rule or a product rule or a composite function rule, so rewrite them first before you take the derivative. Now, if I want you to find the equation of a tangent line to the graph of f at the indicated point, and then graph it on the calculator to confirm, first of all, we want to rewrite f because that's in a form that we can't take the derivative right now. So one thing we're going to do is rewrite the powers. X cubed, but then the fifth root is like a 1/5 power. So 3 times 1/5 is 3/5. I always remember that the power is like power lines, they're up high, and roots, the fifth root, are low under the ground, so 3/5. And then rewrite it one more time because we can't take the derivative of a quotient the way it is. So then the 3/5 comes up to the top as negative 3/5. Okay, now we can take the derivative, so be careful as you're rewriting and differentiating that you keep straight which am I doing. Am I taking the derivative or am I rewriting it? Because often you might be rewriting and taking the derivative of different pieces at the same time and get messed up, so be careful. Okay, derivative. Take the exponent, multiply it by the coefficient, so we're going to have positive 3/5. And then subtract 1 from the exponent. Negative 3/5 minus 1 is the same as minus 5/5. So that's going to be 3/5 x to the negative 8/5. And if you rewrite that, it's, oh, I wrote an x down there. Sorry about that. Okay, 3/5, and then that negative exponent means that the x really should be in the denominator here. So that's my derivative, that's the slope, right? Slope at every x value. I want the slope where? I want the slope at 32. So this notation of drawing a bar and putting it, what value you want there is commonly used. So we're going to do 3/5, 32 to the 8/5. So 3/5, the fifth root of 32 is 2, so I need 2 to the 8th, and then 5 times 2 to the 8th. So I'll do that in the calculator. 2 to the 8th is 256, so it's 5 times 256. 1280. So my slope is 3 over 1280. Really beautiful slope I chose there, huh? Write the equation of the tangent line. So I've got my slope, I've got a point. This is just algebra 1. Y minus y1 equals m times x minus x1. Distribute. So this is 3 over 1280x minus 3 over 40. And then this is y plus 1/8. So I'm going to subtract 1/8 from both sides. 1/8 is the same as 5 over 40. So I have y equals 3 over 1280 x minus 8 over 40. And 8 over 40 reduces to 1/5. Okay, there's your equation of the tangent line. If it doesn't say what form you have to leave it in, you technically could just leave it like that. Then if you make errors here, you won't get docked for them. So they won't go back and look at the last place you had the right answer. If this is a free response question and they don't tell you how to leave your answer, just stop right here. This is your equation of your tangent line. Because anything you do wrong down here, you'll get docked for. So if your final answer is incorrect because you forgot a negative sign or something, you'll get it wrong even though you had it right here. So stop here unless they tell you to go farther. Now we have to graph it on our calculator, so we're going to put it in this form so we can graph it. So all you would do is on your calculator, you're going to type in y1, you're going to type -1 divided by x to the parentheses 3/5. Or if your calculator is already in the new updated version, you can just put in your powers 3/5. So that's y1, and then y2, we're going to put this. And then you should be able to get your window big enough to get up to 32. So I would choose like 0 to 35 for my window at least. And then you should be able to see that this is a tangent line to the graph of that. The next example is to determine the points, if any, at which the graph has a horizontal tangent line. Okay, this is the graph. We've got to find where it has a horizontal tangent line. You should be able to make the connection in your mind. The horizontal tangent line has a slope of what? So horizontal lines go like this, right? Slope of 0. We also should think about the slope being the derivative. So these connections are very vital for doing these problems in calculus. You have to think horizontal tangent line, what does that mean? It means the slope is 0. Well, the slope is just the derivative. So if I take my derivative and force it to be 0, then I'll be finding the place where the graph has a horizontal tangent line. So let's take the derivative. Derivative of square root of 3x is square root of 3 times the derivative of x, which is just 1. The derivative of 2 cosine x is 2 times the derivative of cosine x, which is negative sine x. So I simplify that, and I get the square root of 3 minus 2 sine x. I want that to equal 0 because I want my slope, which is this, to be horizontal. I want my tangent line to be horizontal, so I want my slope to be 0. So set it equal to 0. Subtract square root of 3 from both sides. Negative 2 sine x equals negative square root of 3. Divide by negative 2. Where does sine x equal square root of 3 over 2? Well, it's lots of places on our unit circle, so they would probably give you a domain like which determine the points, if any, so more than one point possibly, maybe between 0 and 2 pi. So thinking about our unit circle, sine is the vertical distance, and in a 30, 60, 90 triangle, the vertical distance being the longer one is at pi over 3. 1/2 is the short, square root of 3 over 2 is the long, and that's at the angle of pi over 3. So x equals pi over 3. Is there any other place where we have a positive sign? Right here, 2 pi over 3. But if we go over here to this part, that's a negative sign, and this is a negative sign. So the only places are here and here, pi over 3 and 2 pi over 3. So those are the points, if any, at which the graph has a horizontal tangent line. Those are the x values. When they say points, though, we should probably plug them in to the function. So our y value would be square root of 3 times pi over 3 plus 2 times cosine of pi over 3. Cosine of pi over 3 is a half. So for the point pi over 3, for the x value pi over 3, our y value is, that's 1. So square root of 3 pi over 3 plus 1. And then for 2 pi over 3, we plug in 2 pi over 3 here. We're going to have square root of 3 times 2 pi over 3, and the cosine there is negative half. So it's 2 pi square root of 3 over 3 minus 1. So those are the 2 points. And there's your homework. So just a few examples for you. Yesterday's video had an example of a problem that will be helpful to you on this section of homework too. So make sure you've watched that.